Okay, so welcome to our notes for rational functions. And the rational functions lesson is part of our unit on polynomial functions because a rational function is a ratio of polynomials. So if you have a polynomial f of x divided by another polynomial g of x, then that would be considered a rational function. So f of x divided by g of x is a rational function. And we looked in the beginning of the year at graphing the reciprocal function 1 over x using transformations. In this lesson, we're going to look at more complicated rational functions and how to graph them. And the steps for graphing rational functions are listed here for you on the front of the notes book that as a quick reference. So first step is to find the holes, if any exist. Second step, to find the vertical asymptote. Then we're going to look for the zeros, if any. We're going to find the y-intercept, if that exists. Then we're going to look for a horizontal or oblique asymptote. It's either one or the other. And then sketch the graph and identify the domain and range. Okay, the way that this notes booklet is structured is we're going to work through 2 problems all the way through all 7 steps. So you'll notice that this polynomial 2x squared minus 8 divided by the polynomial x squared minus x minus 6, for example A, follows as example A through all of the steps in the notes booklet, and then on the back we end up graphing that example A. Okay, so then example B also, it follows through all 7 steps as we turn each page. Example B is the same polynomial. I didn't have room to graph example B on the booklet, so we're going to do that on a whiteboard or on separate paper. So we're going to begin with step 1, which is looking for holes if any exist. And to do that, first we're going to factor completely and cancel out any common factors. So when we look at example A, in the numerator, 2x squared minus 8 has a GCF, a greatest common factor, of 2. So I'm going to go ahead and factor out that 2 to the front, and that leaves me with x squared minus 4 in the numerator. And then x squared minus 4 is a difference of squares. So I can factor that difference of squares as x plus 2 times the quantity x minus 2. And now the numerator is completely factored. In the denominator, I have a quadratic trinomial x squared minus x minus 6. So I'm going to use my crisscross and look for factors of negative 6 that add to equal negative 1. And those factors would be negative 3 and positive 2. So I can factor that trinomial as x minus 3 times the quantity x plus 2. And those 2 linear factors are factored completely, so I'll just copy those over to my now completely factored form. Okay, so step number 1 was to factor completely and to cancel out any common factors. And I can see that in the numerator, there's a factor of x plus 2, and that corresponds with a factor of x plus 2 in the denominator. So those x plus 2 factors cancel. Nothing else matches, and so I'll be left with 2 times the quantity x minus 2, all divided by x minus 3. Okay, now step number 2 says to factor, or any factors that cancel, those will form holes in the graph. And to find the x value of the hole, set the canceled factor equal to 0 and solve for x. So the canceled factor was an x plus 2. So to find my hole, I'm going to take that x plus 2, set it equal to 0, and then solve for x. So I subtract 2 from both sides, and x equals negative 2 that is the x coordinate of the whole in my graph. Okay, now it says that I can substitute that x back into the simplified form to find the y value of the whole. So now to find my y coordinate of the whole, I'm going to take this x equals -2 and substitute it into this simplified form. So 2 times the quantity 2 minus, that should be 2 times -2 minus 2, all divided by -2 minus 3. So that's going to simplify to -4 times 2 is -8, divided by -5 will be a positive 8/5. And that's the y coordinate of my whole. So this graph has a whole of -2, 8/5. So in example B, our numerator polynomial x cubed minus 2x squared minus 15x plus 36 is a 4-term cubic, and that we can't factor using a crisscross. So instead we're going to put that into the graphing calculator, and those screenshots are shown here for you. So we can see from analyzing the graph that there's a real zero at -4, and that's a cross, right? So that's going to be a factor of x plus 4. Okay, then we have a bounce at x equals 3, and that has to have even multiplicity. Since the degree of the numerator is 3 and we already have a linear factor, then that bounce has to have multiplicity of 2. So our factor is x minus 3 with multiplicity 2. Then the denominator, x squared minus 9, is a difference of squares. So that's going to factor as x plus 3, x minus 3. Okay, then we're going to cancel our common factor, and x minus 3 has multiplicity 2 in the numerator. So when I cancel with the one that's in the denominator, that only eliminates the multiplicity and leaves a factor of x minus 3 in the numerator. So my completely factored form is x plus 4, x minus 3 in the numerator, and then x plus 3 in the denominator. So now we're at step number 2, where to find the whole in the graph, we're going to set the canceled factor equal to 0 and solve for x. So our canceled factor was an x minus 3, so the x coordinate of the whole is going to be x minus 3 equals 0, and we add 3 to both sides, and x equals 3. Okay, then our last step is to substitute that x back into the simplified form to find the y coordinate of the whole. And our simplified form is x plus 4, x minus 3 divided by x plus 3. So the y coordinate of the whole, we're going to put 3 in for those x's. And we end up with 7 times 0, which is 0, divided by 6, and 0 divided by 6 is 0. So we have a whole in this graph located at 3, 0.